presentation should be in English, right? My name is Maciej Kalkowski, and I want to show you the way of optimizing almost anything in your life. Basing on Magento in the second part of my presentation, but in the first part I'm going to show you the theory which helps optimize anything in your life. We'll see in a moment. So, why are we optimizing Magento? Anybody can tell me? Why are we? We are here on the performance track, and we want to optimize Magento so it has better performance. So, well, we want to achieve better user experience on our site, right? Why?
Because it's very slow.
Magento is, well, at the very beginning, Magento is really slow. Even if you don't have anything in there, it's just slow. But generally, why we are optimizing? We want to sell more. Why do we want to sell more? We want to have better profit, greater revenue. We want to achieve some goals. So, we need to know what is the goal in our everyday life, other company, at anything we are doing. So when we are on a vacation and we're checking our emails, we are not doing the right thing. We're not achieving the goal to rest. Well, I read a book about it by Elia Goldblatt. It's a theory, he created the theory of constraints. The book is called The Goal. He based his approach on the production lines. So you probably may imagine the production line of a car. At the very end of my presentation, I can show you a burger version of production line, but let's not stick to this for now. And the theory of constraints says that when we have some assumptions, let's say we have the goal set for us. We want to sell more. We want to learn new language. We need some measurements defined. We need to know whether we're getting closer to the goal or not. And well, in Magento we have some measurements, right? The time the page is loaded and presented to our user may be one of the measurements for our goal. Also, the conversion, which is crucial in e-commerce. In the book, in the production lines version, well, they had really huge problems with keeping the deadlines for their production. But they finally found that they should see the production line as the system in which some things go through the line, and they should identify the constraint or constraints of the system. Then they should exploit the constraint. Do everything to exploit this constraint. Then the whole system constraint is elevated. So we need to go back to the step one. Generally, it's I'm not going to focus on the theory of constraints since we are at the Magento conference. So I don't want to talk about something else than Magento. We can see systems, or even the company, the whole company in which we have some employees doing some work, as a flow system. It's really similar to what I do since I work at a university. I'm an adjunct professor. I finished my PhD in graph theory, and this is strictly graph theory. We see what's the maximum flow in this system. And well, you know, it's a simple system. It's a really simple system. But when we look at the system, just putting this vertex a little bit higher to the left, we can see that the maximum flow is 18 in this system. From the left to the right, maximum flow will be 18, right? I'm not wrong. I just checked it a few minutes before, so it should be this way, yeah. So, we want to exploit the system constraints. What the standard developer, Magento developer or system engineer does when he wants to exploit something. He first analyzes this. In performance, we locate the bottleneck and expand the bottleneck. It's quite easy, right? With Magento. In the book, they said that, well, in the production line they found 4 steps to expand the bottleneck. First is to broaden it. So just buy a bigger server, and we're going to be 2 times faster. We can remove some workload from the bottleneck. So if particular part in the production line doesn't need to be processed by the bottleneck, we just don't do this. Since the bottleneck is the heart of our system, the bottleneck defines the performance of our system. What they also figured, and we cannot apply this to Magento, in the production line, they did the quality check before processing the part by the bottleneck. So the bottleneck doesn't process the bad parts, which will be thrown away at the very end of the production line. And they marked the parts which were already processed by the bottleneck, so the people processing this particular part will provide the extraordinary care after processing by the bottleneck. So there will be no thrown away parts after the whole process. So let's get back to Magento, since I was supposed to say something about Magento and performance here. Generally, Magento in a scenario A can be run on just a standard virtual machine with, PHP, MySQL, Magento app, some web server or Linux usually. Does anyone here have Magento on Windows? No.
Yes.
Oh.
I have one customer, people.
Really?
Yes.
Interesting. Well, usually it's like this. We can see a scenario B in which we see that there are 2 different parts of the Magento. It's the HTTP web server part with Magento app, and we have MySQL on the back end. So this will be more easy to scale in a moment. So how do we scale in a standard cloud way? We want to have a cloud approach. So we add second Magento app with web server, and we have 2 front servers providing content for our customers, and we're happy with this. Of course, we need to remember that we should put some Redis with sessions maybe, or we should synchronize our sessions so the customer which is served by VM1, when load balancing will put him on VM2, the session will be kept. Yeah. Does anyone did that kind of scaling of Magento? It looks easy. But we're looking for a bottleneck of our system. We are looking for the constraint of our system. So I'm going to give you a little hint. We can scale Magento apps really easy, right? We can add 100 virtual machines with HTTP server, Magento, PHP 7, even so it's going to be faster. But where is the bottleneck here? database server. So scaling Magento the way it is done in cloud apps, in which you just launch a huge amount of instances, is not the solution here. It helps. It always helps, but it's not the real solution for the problem. If we want to scale for real, we need to do something else. So the bottleneck here is the database. And well, I wanted to explain to you guys the CAP theory, which says that scaling database like we do in the clouds horizontally is impossible. It's generally when we're going to have two distributed MySQL master servers, it's not the best, it's impossible to scale it linearly, just multiplying the instances. But the theory of constraints helps us a little bit. We know that we need to broaden the bottleneck. So we need the database server to run faster. And of course what we usually do, well, we can see what are the parameters of a standard server. I removed some I/O input-output devices like the display, the keyboard, mouse. We have our network internet card. So we don't have, we're going to focus only on these three things. We have CPU, we have RAM, and we have storage. And does anyone heard about such a thing like ACID in relational databases? What D stands for? D stands for durability, right. R, atomicity, consistency, isolation, and durability. So I'm gonna give I'm a lecturer, and I even once or even a few times did a lecture about databases, so I could explain to you like 90 minutes about this ACID, but durability is actually here really important. Durability says that the changes we do in our database are durable. It's gonna be, these changes will be written here on our storage. So, if we want to scale the database, we really need to focus on storage. Of course, speeding up CPU is important. Adding more RAM is really important. It helps process faster, but still, in durability, we need to write it to our drives. And this part is the real bottleneck, the hardest to scale bottleneck in database systems. So, let's get back for a moment. The storage has some capacity, redundancy, it has cache, which should be kept at least by the battery. If the system reboots, the cache will not be lost. And we have IOPS, the input-output operations per second, which are really important here, since it means that your changes to the database were written on a disk, on a drive. So how should we approach the problem from the theory of constraints perspective, broadening, expanding the bottleneck in drives? We should broaden our input-output operations per second. And what we can do is we can build write on drives, redundant array of independent disks. We can add some hardware controllers to drives so they run faster. We also can, by software like moving from MySQL to Percona, we can just tune the database so it runs faster. There should be theory of constraints number 2. Remove from the bottleneck unnecessary workload. This is the second step which the theory of constraints gives us. So when we'll have this system with multiple Magento apps, with sessions synchronized, we have VM3 with MySQL database. How we can remove some workload from the database? The master, I will already give you a hint. We can replicate to slave database and put some load to the slave database. When you're doing some select queries to our database, which are not that crucial, like you want to analyze what happened last month. Nothing is going to change in this query today. So we can easily put this query to the slave database, not to the master one. So in master, of course, when you're adding something to cart, when we're changing the stock in our warehouse management system or anything, when we're doing something which is dynamic and needs to be written to drives and it updates our database, it needs to be written here. But when we're doing some analytics or some queries that are not so important, we can do this on slave, which helps us speeding up the master. It has some workload, additional workload. What we can also do, and probably most of you know this, we can add the varnish cache in front of our system. So, not that many requests from our user go to our infrastructure. It generally helps us remove workload from the whole system. If we have static content or some web pages that are updated once a day, it can be served by Varnish. And Varnish works the way that it should have all the content it caches in the RAM. And even the smallest server possible with 1 core, 1 gig of RAM, and some drives can serve up to 1 gigabit of traffic if it goes directly from RAM to the user. How we can also remove some workload from our databases? We can not only cache in Redis the sessions, but we can also cache some results of our queries to the database. So nothing goes down if it can be cached by Redis. You know that you can cache some content in Redis. It can be any type of content, even binary. We can use some external additional tools like Solar Elasticsearch, RabbitMQ for synchronous processing of data. So not that many, so less requests will go to our database. And what they didn't say in theory of constraints, but we should be smart always. It's we who can optimize SQL queries, do some joins, accept standard Cartesian product of our query. We can optimize our code, build better algorithms. And so this is we who are responsible for the performance of our infrastructure, since we can do a lot optimizing queries and algorithms. And actually, that's it, my presentation. I hope it helped you. It generally can help you optimize anything, so you always need to look for the bottleneck in your life. When you want to achieve the goal, you need to see whether you're spending enough time on achieving this goal and whether the particular thing you're doing right now gets you closer to the goal. And that's what we can do also in Magento infrastructure. And that's it, my presentation.